In this segment, what we're going to be doing is we're going to be taking a look at the ways that heat exchangers are classified. And so the two ways that we classify heat exchangers, we look at the way that the flow is arranged, and we'll be looking at examples of that. You can have parallel flow, you can have cross flow, you can have mixed fluid, unmixed fluid, and the type of construction. And there are different types of construction. We've already seen in the previous segment looking at different types of construction of heat exchangers. But these are the ways that we classify heat exchangers, and it also guides our analysis. Depending upon which equations we would apply, it would depend on the type of construction or the flow arrangement. So what we're going to begin with, we're going to begin with the most simple type of design of a heat exchanger, and that's where you have two pipes, one smaller diameter than the other. They're coaxial, and you have fluid going either in parallel or in counterflow with respect to one another, and there's heat exchange between the pipe wall, between the two pipes. So let's begin looking at that. Okay, so here we have two different types of flow arrangements for what we refer to as being the double pipe heat exchanger. And in both of the figures, one over here, that is inner tube flow as well. And then on the outside, we have what we refer to as being our outer tube flow. Now, with these two, these are basically the same type of construction. The only difference is the direction of the fluid. And we would refer to the one on the left as being the parallel flow configuration or arrangement. And that is because you can see the two fluid streams are going in the same direction. And that is why we call it parallel flow. And then all of the heat transfer is taking place across this interface here and here. So that is where our heat exchange is taking place. And then the design on the right, that we refer to as being the counterflow flow arrangement. So those are two examples of the simplest, which is the double pipe or concentric tube heat exchanger. Another flow arrangement and type of construction that we have is that for cross flow. So a cross flow heat exchanger. So this is a different type of construction. And this is one where what we have is a tube bundle. And so out of each of these tubes, we would have flow coming out. And then going perpendicular to that, or near perpendicular, we would have a cross flow. And for this particular type of construction, you can have fins or no fins on your tube bundle. And depending upon the type of construction, if you do have fins, you may have a scenario where the cross flow does not mix with itself. And so if you imagine if you have fins that are all connected, so if you had fins that were going like this and going across all of them, and then another set of fins, that's kind of a poor drawing. Okay. So then another set of fins going like that, and then another one. So if you have fins like that, what's going to happen is the fluid will not be able to mix in the cross plane in terms of the cross flow. And the tube flow, obviously the fluid there is not going to mix because they are all in individual tubes. So you can have mixed and unmixed, and you can have finned and unfinned, different types of configurations for cross flow heat exchangers. But typically this one, although not exclusively, but quite often, this would be gas to liquid is what we're looking at for the heat exchange. And when I say liquid, it may not be a liquid, it could be a vapor going to a liquid. And that would be the case of condensation. And I guess you could also be going through a phase change the other way, going from liquid to vapor, depending upon the particular design. But anyway, typically gas to liquid, that is the cross-flow heat exchanger. So it's another type of construction. And again, you can have different flow arrangements, just like I said, depending on if it's mixed or unmixed, if you have fins or no fins. And then the next type of heat exchanger that we're going to look at, these are heavier units that are used in many industrial applications, but these are shell and tube heat exchangers. So let's take a look. Now the arrangement is going to depend upon how many shell and tube passes you actually have. You can have two shell units sitting next to each other, shell and tube, and then you would be going through two shells there. Or the tubes, you can actually have them do multi-pass in a single unit. There are all different types of geometrical configurations that you can have for this. But let me just show you the most basic one. Okay, so what do we have here? Let's label the different things that are in here. Now, to begin with, we have fluid coming in, and that is on our tube inlet. And what's going to happen is that fluid is going to come into this manifold on the end, and it is going to be forced to go into these tubes. And then it is going to flow along the tubes, like so. And you'll have hundreds and hundreds of these tubes. Well, it depends on the construction, but many, many tubes. And then it comes out, and it comes into another manifold where there is some mixing. But then it goes out through this exit here, and that is our tube outlet. Now, there will be another flow coming along here, and this is referred to as being the shell inlet, because that will be on the outside. There's a shell outside of our tube bundle, which is on the inside, and the shell flow is forced to go normal or cross flow across our tube sheet, and then it comes here and it turns direction and goes around, and then it comes and it turns direction again. Oh, that's a very big section there. Typically they wouldn't look that way. I am not an artist, I apologize, but you get the idea. We're engineers, we can figure it out. Okay, so what's happening is the flow is going through like that, and then it's coming out in this direction, shell outlet. So that is the direction of the two fluid streams, and we have a couple of other things in the construction here that I would like to point out. First of all, there are these plates here. You can see two of them in my drawing. These are called baffles or baffle plates, and there are different designs that they have. Sometimes they'll have designs where it's like a helical pattern, and you get more efficient mixing that way. Because what will happen if you look at the fluid mechanics here, this is horrible fluid mechanically. You're going to have massive separation downstream of these baffles when the flow comes around, and you'll have significant pressure drop. Usually we're not worried about that much pressure drop with these units. Well, you'll have a lot of pressure drop, but you have a lot of, you'd have a big pump circulating the fluid through, so pressure drop is usually not your main concern. But nonetheless, you're going to have separated flow downstream of these baffles, and that will minimize the heat transfer that you're having in these regions here. So sometimes they'll change the baffles, different types of design in order to enhance mixing. The other thing that we have with the construction on this side is a tube sheet, and on the other side is another tube sheet. And so that is where the tubes come through, and they're usually welded to that tube sheet. In terms of the baffles, they wouldn't be, typically they're not welded. They are free to move back and forth if they need to. But you want to have the baffles there to minimize flow vibration. You can have flow vibration in these things, and it also forces the flow to go around multiple times. So that's kind of a poor drawing of a shell and tube heat exchanger, but hopefully you get the idea in terms of what is going on. So and there we have shell flow forces the flow normal to the tubes, as we mentioned, and we have baffles inside of the unit. They support the tubes. Now if you look at the tube sheet and you take a look at what it looks like, the tube sheet will span obviously the entire cylindrical of the shell, and within the sheet itself we're going to have all these little holes drilled, and that is where our tube bundle is going to come through. And it'll go on. So that is what the tube sheet looks like. Now if you look at a baffle plate, it will not span the entire, so it will look more like this. And there'll be a cutout, and that's where the fluid comes around. But then you would have enough to support the tubes. And you'll notice that, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. Hey, I did this good. I did it well. You actually have a couple of tubes, or a number of tubes here that are free span. And so they are not confined by a baffle at that location. But that is to allow the fluid to get by. So if we look back at the shell and tube, you have this, and then you have this, and you have this. So the fluid is going around like that. And that's why you don't want the baffle plate to go all the way throughout the entire cross section of your shell. So that is the shell and tube heat exchanger. There is another design, although we're not going to look at it in the lectures here, but these are compact heat exchangers. So compact heat exchangers are designed in a manner where you try to maximize the contact area between the two fluid streams. And so these are ones that have very, very large contact area. You could have plates connected together with gaskets, and the fluid goes between those plates. We won't be examining those, but that is another form of heat exchanger. And they're called compact because they're small in terms of how much space they take, but they're very effective in terms of transferring thermal energy from one fluid stream to another. So those are different designs or configurations, types of construction, as well as different flow arrangements. What we'll be doing in the next segment is taking a look at the temperature distributions between the fluid streams in these heat exchangers.